All right, welcome everyone to this week's webinar. This week I'm going to be covering the Introduction to Object-Oriented Programming 101 session from June. The recording back in June didn't go so well, so we're repeating this session so that we can get it up on YouTube and people will have a complete set of our object-oriented programming sessions. So without further ado, I will jump right in here and remind you, of course, always type in your questions as I'm talking. I see them on another screen, and I'll get to them when I have a break. All right, let's see here. So, Introduction to Object-Oriented Programming. Well, if you've been using Xojo for any length of time, you're probably aware that it is object-oriented. So today we're going to talk about some of the basics of object-oriented programming and how you can take advantage of that using Xojo. So the first thing is about objects. So what is an object? It's an abstraction. It's a way to represent something so that it is simpler to understand. And that's the main thing when you're programming, is you want to create your code and your apps so that they're easy to understand. You want to simplify the problem you're working with. And objects can really help with that. And one way to think of an object is just that it's a fancy variable. So what does it actually consist of? Well, like I said, you can think of an object as a fancy variable. Now, you've all used variables in your code. You've used things like strings and integers and doubles or whatnot. And those are simple variables. They can only store one thing. But an object, being a fancy variable, can contain all kinds of things. And these things are generally related. It wouldn't be a very good object if it had a bunch of random things in it. So you want to have your object contain related information. And this information is stored in the object using something called properties, which are essentially things that use the simple data types like string and integer and double and that sort of thing to retain values. But you can also put methods on an object to allow it to do actions or to manipulate things. An object is completely independent from other objects in that when you create an object, it has its own values for its properties. And you can create a second object that will be completely independent. It can have different values. And you can't really do that with a variable. A variable that's in your method, if you assign it a new value, well, it replaces the old value. And you can't have two copies of the same variable. But you can have two what are called instances of an object at one time. And essentially, an object has a type. What is the type of an object? Well, the type of the object is the class, which is also the object definition. So taking a step back, the class is the fundamental building block of object-oriented programming. It defines the object itself. It defines its methods. It defines its properties and anything else you can put on an object. An object can, of course, contain other things. Method and properties are the most typical things. You can put constants on there. There's different types of methods and properties, that sort of thing. The actual object is what I mentioned earlier, is an instance of a class. It takes the class definition, and you say, I want to create an object based on that class. That assigns the class definition to a variable, gives you a place in memory to start to store all these access to all these properties, use the methods and whatnot. What we're going to do in Xojo is take a look at an example class for storing vehicles, for dealing with vehicles. And this class is going to be called vehicle. It's going to have a few properties on it, maybe a method, but we're going to jump into Xojo now and take a look. But before we jump into the object-oriented example, I want to take you through what an example might look like if you weren't using a class or an object to create this type of example. And then we'll see how the implementation works when you do kind of switch over to using a class. So here is our little example project, and I'll just run this. And you can type in vehicles in the little window here and hit the add button, and they're added to the list. You can add mileage to a particular vehicle if it's selected, and you can click the details button to see the information and edit it. So a very simple app. So you can see there's just a single window here. And if we take a look at the main part, what we're dealing with for the code, when we add a new vehicle, if we're not using object-oriented, you commonly see something like this, where people are going to have a bunch of arrays needed to maintain the data that they're tracking. Now in this particular case, you can see I have 3 properties on this window that are defined as arrays, make, mileage, and model. And they are simply properties that are on the window. So in my code here, I have to append what the user typed in from each of the fields to the array. And I also have to append a starting value for the mileage as well, so that these arrays all stay in sync. Because you have to, the way we've got this in a very simple design is that, item 2, you get item 2 for make, for model, and mileage, and those 3 things are all related. Now this works just fine, but it starts to get out of hand pretty quickly. So looking here at the details button, actually before we jump to the details button, let's look at the mileage button. And this is the code that adds mileage to a particular selected vehicle. Now if you look back at the window, see we have a button and a field where you can type the mileage. So here we're just getting what was right here, the integer value of whatever the selected row is. And then we're updating the array at that particular index with whatever the user typed. And we're adding it to the existing mileage. Again, pretty straightforward code, very simple math there. And then if we look lastly at actually we'll jump at the last 2 things of code here. The load code is simply going through our array, and since the arrays should all have the same number of items in them, we just use the U-bound of one of them, and we loop through and we add the values for each of the array right to the list box. One thing I'm doing here to kind of circumvent a possible bug, which is easy to run into if you're using this sort of technique, is that it would be easy to rely on the index to look up the item in the array. So you could rely on the list box index to look up the item in the array. But the thing to remember is those are not always going to be in sync. If you sorted the list box, for example, you probably would get different list box rows and they wouldn't match up to the rows you think are in the array, and you would have a pretty weird looking bug there. So what we're doing is we're saving the actual item index we want in the row tag of the list box so that we can get it later. Lastly, the details button, and this is what opens up the editing window, creates a new editing window and then sets the values that are in the list box, calls a method on that window to send the values in so they can be displayed in the window. The window gets displayed, and then when the window is closed, we figure out what index was selected, and then we update the 2 arrays with the make and model in case they happen to be changed on that window. So like I said, this is what this sort of thing can look like if you're not using an object-oriented design. You've got some arrays, you're storing the value, you're passing the array values around, you're having to remember array indices, making sure you deal with everything as a group, that sort of thing. Now let's take a look at how you could tweak this a little bit by using a class. So this is right here is the class vehicle. And you can see that it has its own definition of properties and a method. Now the properties are make and model, of course. Those are just defined here as strings. But the mileage property looks a little different. And there's also a method related to it called add mileage. Now, one thing that you can take advantage of by creating this as a class is, generally speaking with vehicles, you don't want to just set the mileage to a particular value. Mileage always just increases. You can only add mileage to a vehicle. Now, with our non-class design, we had direct access to the value. So we could just change it to whatever we wanted. But with this particular class design, you can't do that. You can see here the mileage property has a little triangle here next to it. This indicates that it's a computed property. That means that there's a getter and a setter that you can write code in to process what happens when it is assigned a value and when you ask for the value. Now here we have code in the get that is simply returning a value in another property. There is no code in the set, which means we cannot actually set the mileage directly. Why couldn't we just use mMileage to set the mileage directly? Well, we can't do that because, as you can see by this little red dot next to it, this property is marked as private. And you can see that right here in the scope field. A private property cannot be set outside the class. So although we can access it in code that's within our class itself, code that creates an object out of the class cannot access this property, so it cannot directly manipulate the mileage. So since we only provided a way to get the mileage, we do want a way to actually, add mileage to the mileage. So I've added a method here. And this takes a parameter, miles, and the miles just get added to the private property, which we are able to access because this code is within the class itself. So let's take a look at how this particular class ends up being used. So we go back to our window. So the first thing here you can see, all right, we want to create a new vehicle. Well, syntax kind of reads like that. We create a variable. Here we're just calling it v, and we're using the syntax new vehicle. Vehicle is the name of our class. New is saying we want a new instance. And the new instance is now available in the v property. Now we have access here to all the public methods and properties. So make and model are properties, and they can be assigned what the user typed in the text field. We are still using an array, as you can see right here. I'll expand it, to store each instance so that we have easy access to them. But notice we just need one array, and we just store the actual vehicle because the array is declared to have a type of vehicle. And you'll remember I said the class is the type. So you can use it as a type name just like you can use string or integer. And then the load list box method does the same as before. It populates the list box with whatever is in the array of vehicles. And you can see the syntax is a little cleaner here because, again, we're just accessing the vehicle directly. And this makes nice use of the for each loop. You can see for each v as vehicle, its type, in our array of vehicles. And then we can just add each row, directly accessing the properties. And similar to what we did in the non-object-oriented design where we were storing the index in the row tag, here we can actually store the object in the row tag so that it is quickly and easily available later. We could have stored the index and then looked it up in our array, but this is just even a little more convenient. And because we just have the single vehicle object or instance that we're passing around, it allows everything to remain, grouped together very easily. So if you look at the add mileage button code, you can see the same sort of thing. It's declaring a object of vehicle. Not a new one though, because we're getting the existing one that we just stuffed in that row tag. And we're assigning it to the vehicle one. Now that we have an existing vehicle, we can call the add mileage method to it and pass in what the user typed for the mileage to add. And lastly, looking at the details button, you can see Same sort of thing, but each time you see this, you can see the code looks a little simpler. The line isn't as long. There's not as many things to parse. You can read it a little clearer, I think. So we're creating the new window. We're creating another vehicle, and we're assigning it to whatever the one was that is selected. And then here we can assign the vehicle itself to a property on the vehicle detail window, and then show the window. And then we just reload the list box when the window is closed. Let's take a look at that window. Now you'll notice I didn't have to reassign anything here. I didn't have to assign what was entered in the vehicle detail window back anywhere. And that's because objects are passed around by reference. So since I passed in the actual object into the vehicle detail, I can make its changes. Those changes are by reference. So this still refers to the changes I made on the vehicle detail window. And when load list box calls, it has direct access to those changes. So you don't have to set anything, which can be very handy. So this here is our property. And again, this is a computed property. And it has in its set code, and it's set as I click on it, you can see the type is set as vehicle. And it saves the vehicle in a private property for future use, and then it just assigns the UI controls with the values that are in the vehicle. And the OK button kind of does the reverse. It assigns what the user typed back to the appropriate properties of our vehicle, and then just closes itself. So again, you can see here the code just looks a little bit simpler, a little easier to read. All right, I'm just scanning any questions here before I move back to the PowerPoint. All right, let's see here. Dwayne is noting it's probably a slight digression, but he's just noting the use of row tags. And let's see if we go back to actually right here is where I'm using the row tags. And row tag is a feature of the list box. Very, very handy. I certainly recommend you try to take advantage of it. A row tag is a way for you to store information in a list box that isn't in any way visible, and it can be any information. So it's very handy for stuff you want to look up later. A common use for putting the row tag in is what I've done here. I'm storing an actual object instance for later use. Another common use is when you're working with databases, you can store the primary key of a row if your list box is displaying data from the database table. But very handy. There's also a companion thing called cell tag that gives you the same sort of thing for each individual cell of a list box. So certainly watch my list box webinars and check out that in the language reference. It's a very handy feature. And Glenn is noting if there are a bunch of vehicles and he says, 20 or so, and you wanted to save the information, would I recommend using JSON or SQLite to save them? Well, certainly there's lots of different ways to save data or persist data, if you will. What you want to use really depends on the amount of data, how easily you need to access and search it. SQLite is probably the most flexible in that manner, probably the speediest as well. So because it is a database, you can query it much faster. A little bit more work to set up, probably a little bit more overhead on the file size. JSON's nice, very lightweight text format. Might be a little harder to parse. XML can also be used, same sort of thing. So, I don't know what I would necessarily recommend. I tend to use a mixture of all three depending on what the particular project's needs are. All right, so this here was a comparison of how you might have a design that does not use a class, but still gets the job done, and a design that does use a class, and in my opinion, is a little simpler, better meets the requirements in how you're able to manipulate the mileage, And probably is going to be a lot more extensible if it turns out you need to add a lot more properties to your vehicle. Maybe you want to track, booleans for, does it have four-wheel drive? What's the engine size? How much legroom does it have? If you start putting all that properties on here, if you go with the first design, you're going to end up with a lot of arrays that you're going to have to start to manage and pass around and keep track of and understand. And it quickly will escalate into something that you're probably not happy with. Whereas if you go with the class design, all those extra things are in the class. Much easier to maintain and understand. Speaking of which, that takes us to some object-oriented programming concepts. Encapsulation is kind of the one I'm talking about, where everything is grouped together. Having all the related properties for a vehicle within a vehicle class is very nice. But encapsulation also allows you to hide things that you don't want people to be able to see. So for example, in our vehicle implementation with the class in Xojo, we used encapsulation to hide or limit how mileage could be modified by using a combination of a method and a computed property. That prevents you or someone else who's working on your project from making a mistake and coding out something that allows the user to directly manipulate something they should not be directly manipulating. You can also do simple things like if your class is starting to get more powerful, it may have methods in there that are internal to the class, and you can just mark those as private so that the class can use them. But others that are accessing the class throughout your application don't have any reason to access. They don't ever see them. So that's the first one, encapsulation, hiding related information that does not need to be exposed. Next, we have the concept of overloading. Now, overloading is pretty neat. It allows you to have multiple methods in the class that have the same name, but they have different parameters, so they can be used differently depending on the context. Let's see how that might work with our vehicle example. Now, the only method we have on our vehicle class here is add mileage. And right now, it takes mileage in the form of miles. Now, if we wanted to add a secondary method that said, well, I want people to add mileage using kilometers. Okay, great. Well, you could add a new method called add mileage using kilometers. Or you could add a method with the same name and just give it a different set of parameters. So let's just come here and add another method. And we'll call it, actually we'll call this, so we'll give it another parameter. We can't give it the same parameter. I couldn't just type a parameter here that said kilometers as integer, because the parameters have to differ in some way. And if they both are one parameter and they both are of type integer, they're not different in any way. The name doesn't count. It's the types or the count of parameters. So that wouldn't work. But adding a type would allow this secondary method to maybe be a more flexible version. So we could do something like, all right, and if we had miles, we could just call our existing property that we have using what was passed in. But if kilometers were passed in, we can do something by, let's see, if kilometers are passed in, kilometers are smaller than a mile, so they're like, well, not 6, but they're like 0.6 of a mile. So we could do that, and this implies, of course, that we're actually still storing the mileage at miles, but you have to pick something. You could have different cases here. You could have something for feet if you wanted to, and let user type in gigantic numbers and then multiply those out to get the miles. So this is an example of a method that's overloaded. All right, let's go back to slide here. All right, and one of the really great things about object-oriented programming is taking advantage of inheritance. Now, inheritance allows you to create a class that is based on an already existing class. Essentially, the class has a parent, or what is typically the term, a superclass. The class with the parent is called a subclass. This subclass takes on all the methods and properties that are in its superclass. But you can override specific methods if you need to in the subclass. So if again we go back to Xojo here, right now we just have our vehicle class here. Now before I create a subclass of that, I want to point out that whenever you're doing your layout design here, and you're adding controls to your layouts, you're using subclasses. As you can see here, when I clicked on this button here, you can see it has a super, and the super is the push button. And the act of actually dragging something from the layout editor, this is a list of classes, you drag it onto here, you're getting essentially an instance of the class created. And you're able to use it because it's going to have super of the class you dragged in from the library, and you can access all its properties and methods to do whatever you want. And it's what makes layouts in Xojo so easy to work with. But you can do that with your own classes as well. So right now we have a vehicle class. I'm not going to go too crazy with how you might subclass this, but if you think about it for a minute, this could be the top level superclass. Maybe you want to create a subclass called truck. Well, I can right click on vehicle and I can click here new subclass. And you can see it already gave it a name and set it super for me. But I can give it a new name, and now I can see that it has a super here. So now it is of type truck, but it is said to inherit from vehicle because its superclass is vehicle. This means if I were to declare something as a truck, I would still be able to access everything on here that's marked as public. I would not be able to access anything that's marked as private. I would be able to access things that are set in a third state. So if I click on one of these, we've talked about public, we've talked about private. There's also a middle state for scope called protected. And protected means that the only people outside of the class that can access it are subclasses. So if I set model here as protected, then only truck would be able to access model. But something that just declared vehicle would not have access to it. It essentially would be private to them. Protected is not nearly as commonly used as public or private. So because I've created truck here as a subclass, I can actually use it in place of vehicle in my code. And I can add new stuff to it. So I could add a new property here that towing capacity. So I could add a new property. I could go back to things here and I could use new truck. And you would see that the autocomplete is still telling me that make, mileage, and model are available as properties that I can access because those are inherited. So that can be very handy. Again, you see it all the time in the Xojo user interface classes. Those have a very strict hierarchy. Other things in Xojo use hierarchy. There doesn't tend to be a very deep hierarchy in that classes have multiple levels deep. But things like the database classes, SQLite is a subclass of the database class. And it allows you to group commonly used things in a higher level class so they can be reused amongst the lower level classes. So right now, just having a single truck property that inherits from vehicle isn't all that useful. But if I had a second one here that was called car, and maybe I added, starting to add more here. Well, then there's, mileage and make and model are all common things with all, truck, cars, and motorcycles. So having that be at a higher level does make some amount of sense. So it allows you to group your things a little bit better so you're not repeating information, and it makes it a little easier to understand. All right, we're going to take a little break here for me to run my polls, and then we'll move on to our next examples. All right, our first poll is, what type of apps do you create using Xojo? I'll run these for about 30 seconds or so, let people answer. It doesn't usually take people too long to click on the little box that pops up. All right, great. Let's move on to the next one. This is, do you have a Xojo Pro license? Xojo Pro is our middle tier license that gives you access to all of Xojo features: desktop, web, console, apps, database, full database support. Plus you have 3 licenses that you can install on up to 3 different workstations. All right, our next poll question is, how long have you been using Xojo? All right, oh boy, everyone went through that one quick. And our last question is, how do you use Xojo? All right, great. That looks like everybody. Thank you, everyone. Now let's continue here. So we're at covered inheritance. So the next high-level topic to cover is something called polymorphism. And this is related to inheritance. And it allows you to have different classes that behave in a uniform manner. Now, we're going to look at 2 ways that you can kind of use polymorphism. One is by using overriding of methods in a subclass. And the other will be by taking advantage of Xojo's events. So let's take a look at a couple Xojo examples here. First, we're going to look at the overriding example. Now, this example is pretty simple. We're just going to have some classes here, and we're going to essentially call them in a way that might not seem completely obvious to you, but a lot of power in this technique. So if we look at the code on the speak button, I'm declaring an array of type animal. I'm adding to this array something of type cat, and then something else of type dog. So I've now added 2 different types to an array of a single type. Kind of unusual. Now, why is it that this works in this particular case? Well, adding them works because cat and dog are subclasses of animal. So if we look at our little class design here, we'll see you have the animal class set up. Very simple. Doesn't inherit from anything because it's the superclass, but it does have a single method on it with no code, but it does have a method. And it's a method called speak, and it returns a string. Dog and cat are subclasses of animal, as you can see right here in the inspector. And if I expand them, you'll see that they also have a speak method that matches the signature of the one in the animal class. Name is speak, return type is string. These are said to be overriding the method that's in the animal class. And you can see they actually have code in theirs. And they're just returning the sound that the particular animal makes. So dog here returns woof, and as you can imagine, the cat's returning meow. Now if we look back at our code, we're adding the cat and the dog to the array. That works because they're subclasses of animal. Now we loop through the array and we call the speak method. We're calling the speak method on the animal class, however, which is right here. But that didn't actually have any code on it. But because it knows, Xojo and object-oriented concepts know that what A actually is, although it is an animal, it is also a cat or a dog. So it determines at runtime which of these it actually is, and it calls the appropriate speak method on it. So when we go through this loop, the first item in the array is a cat. It's going to determine this, and it's going to call the speak method on the cat class, and it'll display meow. And then the second one we know is dog, and it's going to display the woof. Just like that. It can be very, very handy to be able to have classes that are different, but still treated as if they're the same. Now, if I put a different method on here, called walk or something, let's just add a method here, and go back to our code. I would not be able to call walk. If we run this, we'll get a compiler error, because walk does not exist on the animal class. It only exists on the dog class. So it's not going to work in this case. We can, however, make it work. Not that it's going to do anything in our particular thing, but at least we won't get a compiler error. We can say if our animal is actually the dog, is a dog, and if it is a dog, then we can call the walk method. And we're almost there. This is still going to give a compiler error because this is still of type animal. Now we know it's a dog, but it's still of type animal. Well, if we know it's a dog, we can say, hey, we know this is a dog. Let's treat it as a dog. So we use this syntax here, which is called casting. And we're casting the animal into a dog because we already know that it is a dog. By doing it in this manner, we are able to run the project without a compilation error. And if actually, since we didn't make dog do anything, let's put a little message box here so we can see that that gets called. So we get the meow, we get the woof, and we get walk the dog. We only got it once because there's only one dog in our array. All right. Now let's take a look at a companion example that does this using event handling rather than overriding of methods. Now the overriding of methods mechanism is nice. And before I jump in, why you would use one over the other is a popular question. And if I add another animal here, actually let's go to animal and hit new subclass. So now I have a bird. Now it's not entirely obvious how I would implement the speak method looking at bird right now. Now I can add a method, and the way to find out what methods are available to override is to go over to the method field. You can click the drop down here, and you can see which methods are available to override. Every class, you can always override the constructor and the destructor, which are talked about in the 201 webinar. But you can see speak is also here. So I could pick this and then know that I can override it by putting some code in here. So that's great. events provide kind of a different way for you to just discover what is available for you to put code in. All right, so let's open that example. So we have here same version using classes with inheritance. Code here is exactly the same as the code in the other example, but the implementation behind the scenes is a little bit different. So if we look at our animal class, we can see that there is still a speak method here, but it actually has code in it. And it is returning whatever comes out of this speak sound event definition that I've put on the animal class. And it just returns a string. Now, there can't be any code in here because this is just an event definition on this class. But the subclasses are able to add this speak sound as an event handler. And in it, they can put the code. Same code as before, return the sound that the animal makes, but it's in an event handler. Now what happens here in our code is it's looping through the animals. It's calling the speak method, and it's always calling this speak method because none are overridden on the subclasses. And it's always calling the speak method, which in turn is calling the event that happens to be implemented on the subclass. So if it's a cat, it's calling this code, and if it's a dog, it's calling that code. And you can see you get the same results as the first example. And if you were to implement your own from scratch, so you come here and you say new subclass, we'll add the bird. Same sort of thing, you don't necessarily see anything there, but if you come to event handlers, you can see the speak sound event handler is right here, ready to be added. And then you can add some code there. And we can continue to add more and more critters to our list, as long as they all inherit from the animal class, their noise gets displayed. So that's how you can implement this sort of thing, polymorphism, using either overridden methods or event handlers. Now, why would you choose one over the other? It depends a lot on what you're used to, what you're comfortable with. The event technique is probably a little more unique to Xojo than the overridden method technique. So if you've worked with other languages, or you are going to be working with other languages, maybe the overridden method technique is something you want to stick with. But the event technique is a lot easier, I think, for people to work with by adding the event handler and knowing right where to put the code in, and not running the risk of creating a method and maybe not populating it quite the right way, or accidentally changing a type on it or something like that. So I think the event method's a little bit safer and fits nicely with Xojo. So I tend to lean towards that one, but either one, as you can see, work perfectly fine. All right. So this, we just covered polymorphism using overriding and event handling. So that looks like that's the end of what I cover in the 101 session. So I will point out the 201 session is actually already on YouTube, because that recording worked perfectly fine. So you can head on over there to grab that and go over that. In that session, other things are covered, such as interfaces, constructors and destructors, and some more advanced things you can use with classes, such as operator overloading and other commands. So you can almost kind of watch these, one right after another. And of course, all the example projects are already available online at the second URL here on our documentation wiki. for the 101 session from June has all these examples I just covered. I will also put up a new link for today's date with the same information, the slides and the examples, so that it's easy for people to find. All right. Let's just open up a little question window here, see if I got any outstanding questions. John is noting that it looks like here he's saying you could add a property array to store waypoints, for example. I guess that's related to the vehicle class, maybe tracking locations that it's been to. And yeah, absolutely. That sort of thing would be related to a specific instance of a vehicle. It probably would make sense that you want to track that if, say, you have a fleet of trucks and you want to track their deliveries or something like that. And that's the beauty of going with classes like this. You can put these related things right where they belong within the class, so that you don't have just random variables and arrays and things scattered throughout your application that you try to have to manage and maintain, and then your app gets much, much more harder to maintain as it grows in features. You certainly don't want to head down that path. All right. Upcoming webinars. We have next week another repeat of a session that had recording issues. Our database webinar will be repeated. And then there's some more that are in the schedule up into September. I still have a few open slots that I haven't finalized topics yet. And certainly, as you can see here, we've got quite a few guest speakers. I'm always open for people that have topics they want to talk about and share with others in the Xojo community. Topics can be really anything as long as they're, somewhat related to Xojo. They don't specifically have to cover, Xojo coding or anything like that. They can just be general programming concepts that are related to Xojo, or anything that would apply to Xojo in some manner or another. I know everyone has something they can share, and it can be kind of fun to do these webinars and share what you know with others. So if it's something you're interested in, by all means, get in touch with me. And of course, I want to remind everyone to check out the Xojo forum. This is a great place to ask questions, help other people, and there's even a getting started channel in our forum. So it's a great place for you to go if you're just starting out on some of these object-oriented concepts and want a little clarification, or have a thing you want to try and want to ask other people's opinion of it. By all means, post here. It's a great place to go. And I did show you the link before, but the video page in our documentation wiki has links where you can subscribe to the YouTube channel, the RSS feed for the YouTube channel, which is a great way to just know when I've actually uploaded new webinars to YouTube. And you can, of course, here as well get access to all the webinars and related example projects. We've done a lot of webinars now, over a year's worth, so they're really starting to pile up. Lots of information here. All right, well, I think that wraps things up for this week. I want to thank everyone for attending, and have a great rest of your day.